Swayam Prabha. Digital India. Educated India.
Hello all, welcome to our NPTEL online certification courses on engineering drawing and computer graphics. We are in module number 3, lecture number 30, and we are covering orthographic projections 1. So, in this orthographic projections 1, we are covering the last topic on points and point projections. The first question what we would like to ask is how to draw projection of any object, especially a point. Further purpose what we require is, we require an object, perhaps it can be camera, it can be a pen, it can be pencil, or it can be a car also. So, each point on that surface of the object, we are going to project it onto a reference plane. So, the things what we require is an object, let us say a car, and we require an observer with an observation perpendicular to reference planes. That means, if this is the car, any point the object, this is the object, any point on the object we are projecting onto a reference plane. Similarly, we might be projecting the top one onto that bottom plane. So, first one is object, this is, second one is observer, we are the ones who are looking at it either from top view, side view or front view in that direction. That is what we call location of objects is position with respect to vertical plane and horizontal plane. I think it should be plane. These are the three things what we require for any projection, because projections are the ones which gives us true dimensions of that object. In the last classes, we have learned about different kind of quadrants, an object located in the first quadrant, second quadrant, third quadrant and fourth quadrant. In these quadrants, we call this one as the vertical plane. If an object is placed in that first quadrant, this object, the kind of projection what it maps onto that plane, what we have called this reference plane. And this plane what we called horizontal plane. And based on the observer, for example, observer, if an object is present there, the projection onto that surface, what we are going to see as the things on this vertical plane and horizontal plane. Based on these planes, when we are folding, unfolding this vertical plane, horizontal plane, we will have this mapping of point A differently on these different planes. For example, let us consider a point which is making a projection on the plane. For example, point A, we are interested in having projection. Though it is placed in quadrant A, this point, the projections what we are going to see is on this vertical plane and on that horizontal plane. So, here point A projected onto vertical plane, this is the vertical plane, and the notation for our engineering drawing is any projection onto vertical plane, we use this prime or dash, and lower case letters indicates the projection things, orthographic projections, and uppercase letters are the true object thing. So, because we have projected onto vertical plane, small a dash. Similarly, this a projection onto that horizontal plane and unfolding this horizontal plane by 90 degrees in the clockwise direction. So, project that, and based on this origin transfer this length or radius in this direction to get point A. On horizontal planes, that is this horizontal plane unfolded, we show it by lower case letters without any dash or primes. So, the terminology is dash for projection onto vertical plane, without dash onto horizontal plane. This is for a point projected in the first quadrant. Let us look at a point in third quadrant if it is projected onto these planes, vertical plane and horizontal plane, how it looks like. Now, the point A, it is in third quadrant, that means in this third quadrant somewhere point A is located, and we are interested in projection of this point A onto different planes. What we have seen is in the third quadrant it will be mainly projected onto that opaque plane, and we are making that opaque plane in clockwise direction by 90 degrees. So, this point onto parallel vertical plane, this is the parallel vertical plane projected onto that, and this entire plane, the mirror, we are making it 90 degrees rotation in this direction to make it a vertical plane. That what we can see here, the point A projected onto this vertical plane. So, A point we want to project it onto that vertical plane, and what we are going to do is always fold, unfold the horizontal planes. So, if we are projecting on the parallel planes either here or on this vertical plane, projection that gives us A prime. Now, this one projected onto horizontal plane, that is this. Once we have that projection, we unfold this horizontal plane by 90 degrees in the clockwise direction, so that this entire horizontal plane comes at this top level. That means, our point with this one as origin, this one as the radius, transfer this radius onto that plane, name it lowercase letter a. And let us look at it again. Once we have this point A, we have to project this point onto corresponding planes. Always we project it onto vertical plane first. Once it is done, we name it A prime, A point to A prime. This point we project it onto horizontal plane, and horizontal plane is made into 90 degrees clockwise direction. So, this one we are going to flip it, so that we can construct this one as the horizontal plane and transfer this projected length in that way and call that one A. Let us look at if a point is in the second quadrant, that means the point is somewhere here A. First thing, we have to project this point onto vertical plane. The vertical plane is this one, let us call this one. This is horizontal plane. Project point A onto vertical plane, and whatever that impression creates, that is A prime, that is point A is there, project that, call A prime. Now, project this one onto this bottom side and fold this by 90 degrees clockwise, so that this horizontal thing, whatever we have projected, that we are uncovering in that direction, so that A will be located. In most of the cases, this plane projections, points, line and other things, either we show it on the plane. So, for example, if I am showing first quadrant plane, vertical plane, maybe we might be showing like vertical plane, horizontal plane. If we are looking normal to that plane, normal to vertical plane and unfolding it, or if we are looking onto this sideways, sideways of that will be, this is the vertical plane, horizontal plane, by flipping 90 degrees we will have this line. So, here we will have horizontal plane. So, if we are going to construct any two dimensional things, we do not show this entire object, the projections we will show it on the vertical plane, on the horizontal plane. In one view this makes a box, in other view it makes like a line. So, on these lines or on these planes we are going to show the projections, and what we are trying to look at is, all the time this vertical plane remains same, but horizontal plane perhaps flipped by 90 degrees in the clockwise direction, so that we show that impression. If it is first quadrant, in that way. If it is in third quadrant, the third quadrant plane, vertical plane remains same, but the horizontal plane is that, and what we do is, keep the vertical plane remains same, the projection we always have that, and the projection we flip it into 90 degrees clockwise, transfer that radially, so that we will have impression. If we are looking from this view, this makes like horizontal plane there, vertical plane there. If we are looking from this direction, it looks like a line, top one is horizontal plane, bottom one is vertical plane. Similarly, if we are in second quadrant, for example here, if we are in second quadrant, vertical plane projection always we keep it there, horizontal projections we might be having it in that way, always we rotate any horizontal plane in the clockwise direction by 90 degrees. If we are doing that, both the planes coincides and we have to transfer this one, let us call A dash and A. If we are looking from this view, it will be a line, and this line, this is vertical plane, horizontal plane also here, and one of the projection is A, other projection is A dash. That is the thing what we are seeing, A dash as the vertical projection, A as the horizontal projection. Let us apply the same rule for the point in fourth quadrant. If it is a fourth quadrant, this is one plane, this is the one, the point projected onto vertical plane remains same, onto horizontal plane we are projecting, rotate this horizontal by 90 degrees and clockwise. If we are making, they will coincide, one of the projection A prime, the other projection A. That is the thing, if we are looking from this side, one is A prime, other one is A. So, here the point A projected onto vertical plane is A dash, projected onto horizontal plane, from their origin rotated by 90 degrees in the clockwise to get projection of A. So, let us look at these projections of points on different quadrants, especially in the first quadrant. If point A is above both horizontal plane and vertical plane. So, to summarize that, any point you pick it A which is above both horizontal plane and vertical plane. So, it is above A, above horizontal plane, and next to this vertical plane above that. If that is kind of projection, if we are going to have it, then the first projection always be towards vertical plane. So, we will denote that one as A dash. The horizontal projection we will have A. To show that, we flip it 90 degrees. If we do that, it looks like this. So, this projection A dash is this one. So, this length OA dash same as OA dash here. Flip this by 90 degrees clockwise, then OA, this distance on that plane remains same as OA distance. It is always convenient to show it in this 2-dimensional framework instead of showing this 3D picture, where we will have clear indication of lengths. That is the reason why we use this kind of projections. Showing 3D objects and having dimensions is always be difficult task finding them. So, if we are projecting these points onto these different planes, it becomes easy for us to measure the distances and reproduce those things. Let us look at if a point A above horizontal plane, but it is on vertical plane. For example, let us pick point A. It is above the horizontal plane, but it is on vertical plane. It is not here somewhere, but it is precisely on that vertical plane. If that is the case, the projections A is already there, by definition it becomes A dash, the projection itself, and if we are projecting A all the way down, it maps on the horizontal plane at O. That means, if we are looking at the 2-dimensional framework, where we are going to make this 90 degrees clockwise for horizontal plane, the A dash on the vertical plane we will see its projection, A projection on horizontal plane precisely maps at O. So, the projection length on the horizontal plane is 0, whereas on vertical plane it is OA prime. Let us ask next question. If point A is on horizontal plane and it is in front of vertical plane. So, this is the vertical plane what we are referring. And the point A is on horizontal plane in front of vertical plane. So, if we are projecting, first projection always be onto vertical plane. It maps to origin O. That is what we call A dash. Now, projection of A, capital A onto horizontal plane gives us this distance. So, if we are flipping this plane, horizontal plane by 90 degrees clockwise, we will get this vertical plane as this and this horizontal by 90 degrees clockwise that. A projected onto origin. So, A prime itself is origin on this xy plane. Xy is the axis which is intersecting both vertical and horizontal plane. So, on that xy we will have A dash precisely mapped at origin, and A there is a distance, that is OA. If a point is on horizontal plane, you will find this true length on horizontal plane, and the projection always gives you 0. Let us summarize this projection of a point on different planes. For example, a point which is in front of vertical plane above the horizontal plane gives a projection on the vertical plane A dash OA and OA dash on the horizontal plane. So, OA on the horizontal plane, OA dash on the vertical plane. What about if I am looking side view projection for this point for the same configuration? The standard notation for first quadrant definition is, first construct this side plane, project that and flip it in the counterclockwise direction. If that is the case, we may be having it possibly somewhere here around, but usually we go with these two dimensional projections like on vertical plane, horizontal plane. So, it will be in this way. Similarly, if we are looking a point precisely on the horizontal plane, above that vertical plane, on the vertical plane, above horizontal plane, that means this point, then its projection gives us A dash on the vertical plane, on horizontal plane at 0 location. If point A is on horizontal plane in front of the vertical plane, OA dash will be this OA and OA dash will be mapped at O location. So, we will have that 0 length. This is the way point projections happens. For example, let us pick an example. Let us consider a point 3 centimeters in front of vertical plane and it is at 5 centimeters above the horizontal plane. That means, it comes under this kind of category, 3 centimeters in this direction, 5 centimeters in this direction. That means, if we are drawing this one x y plane, above that locate a point A dash, call this one O, project it. Similarly, this point is A, project it, so that this dimension becomes 50 mm and this dimension becomes 30 mm. So, in the next class we will learn more about line projections. Thank you very much.